Hey, good morning, good afternoon, good evening, and good night. My name is Chinamaram Chibo, and we're back here with yet another video. Today we're actually doing something a little bit different. We're on this website called LeetCode, where you do some programming questions. And I just thought, since I'm doing this, I've been doing way too many of these problems as of late. So I thought I'd just share it with you guys because I find it really fun. And I think it's also helpful for me to explain my thought process. So I'm just close some unnecessary tabs. And yeah, we'll just jump right into it. So the question is called Deepest Leaves Sum, question 1302, in case you want to try it beforehand. And it says that given a root of a binary tree, return the sum of values of its deepest leaves. Okay, so let's look at the examples and see exactly what it's saying. So this is a binary tree, and it just has nodes connected to other nodes. And it wants us to find the sum of the deepest leaves. So this and this would be the deepest leaves in this case. So I would somehow need to find this leaf and also find this leaf. Okay, interesting. And if we had this, the deepest leaf would be 19, and why is that? Let's see. One cool thing about LeetCode is you can actually just take this input and put it in here and then see what the tree looks like. So we can see why it's 19, because it's 9 plus 1, which is 10, plus 4 plus 5, which is 9. So 19, 10 plus 9. Okay, that makes perfect sense. So I wrote a little bit, but I'm gonna first explain my thought process. So I'm gonna start at the top, and when traversing trees, like when going through a tree, there are usually two ways you can do it. You could either start at the top and go to the bottom all the way, and then find another path and go to the bottom all the way there, then find another path and go to the bottom all the way there, and so on. Or you can do and that's called like depth first search, whereas breadth first search is doing like level order traversal. So do this level, and then this level, and then this level, and notice how this looks like this. And I'm thinking I'm probably going to do the second one, because if I go level by level, at the last level I would basically have these bottom guys. So if I search through this tree and I go level by level, so I go first from 1, then I go to 2 and 3, then I go to 4, 5, and 6, then I go to 7 and 8. Right at this last time would be when I have the correct sum, and then I could just return that. And so that's called a breadth first search, because you're not going deep, you're going wide almost. You go through like the whole breadth of the tree, or like width. So I'm just gonna make a function called BFS, short for breadth first search, and it's gonna take in, what should it take in? Well, I need to have some sort of list to keep track of the current layer I'm on. So I'm gonna make that list, and it's gonna start with root, because the root is just the first node in the tree. And then I'm also gonna call this function. So that's just calling BFS and passing in this root node. This should actually be here, and let's call that the node list, because that's the list of all of the nodes in one layer. And so we're gonna iterate layer by layer going down this tree. So we start at the root, and then we need to find all of the root's children, right? So we will go and we will find the children in the root. So we have the node list, and we're gonna make a new node list, and we're gonna make it empty. And for each element in this old node list, so for I in node list, what we're gonna do is we're gonna add it to this new list. So that would be the left and the right. So we'd want to add the left and the right of each element in the node list. So say we're on layer 2, we'd want to add the left and the right of this 2 and the left and the right of this 3. So at layer 1, there's just one item in the node list, and then we add its left and its right, then there are 2 items in the node list. Then we add their left and their right, and their left and their right. And then there's 3 items in the node list. We add their left and their right, their left and their right. And notice how some of these have no left? Well, then we just add none, which we just basically don't add anything. So for I in node list, I'm going to add its left and its right to this new node list if the left and the right exists. So first I'll check if the left exists. So if i.left, then I'm going to want to add that left element to the new node list. So new node list, I can say .append and add that i.left to the new node list. And I will do the same for the right hand side. So do the same with i.right. And we will append the rightmost element. And now both of these elements should be in this new node list. And now since we're going layer by layer, I would want to now do the same thing for this new layer. So basically this can be done recursively. I could also do it iteratively after. So that just means recursively means I start with this layer and then I do the same function again for this layer and then the same function again for the next layer. So I can call a function within itself. So this would call the same breadth first search, but now starting on the second layer. So that would have all of the items in the node list. So I would do that out here and I would just say return BFS and then with the new items in the node list. So I would put that here because that's the new node list and it has all of the new items. And I would also need a terminating condition. So when should I stop doing the BFS and what should I return? So I would probably want to stop when there are no items in this new node list. So if there are items, I will continue. So if new node list, so this just checks if it's empty or not. So if it was empty, this would return false. So if it's true, if there are items in the new node list, I'm going to continue doing the BFS. And then otherwise, I could write else, but I could also just write return. And then I want to return what? I want to return 7 and 8. So I'm thinking those would probably be in the current node list because the new node list would be empty, but the current node list would have the 7 and the 8. So I would want to return the sum of 7 and 8. And there would be 2 elements in the node list. So what I can do is I could return the sum, and this is, so for each element in this node list, I'm going to want to return their values. So right now they're being stored as nodes, but I could say i.val for I in node list. And that would return the value for each element in this final node list, I think. I haven't tried any of this out, so it may or may not work. And it almost definitely doesn't work the first try, but I think the general idea is there. So we start at the top layer, and then layer by layer, we keep adding these to new node lists and doing the same function for each new layer. So we start at the top layer, then we go to the second layer, then the third layer, and then finally when we're at this last layer, none of them have any children, right? They have no nodes beneath them. So we would see that the new node list would get nothing appended to it because this would have nothing and this would have nothing. And so the new node list would be empty. And so instead of returning BFS, we would now return the sum of I in the past node list. So 7 and 8, hopefully. This never works the first try though. So we're going to have to see what we can change when it eventually doesn't work. Okay, so we returned nothing. That's fun. I should probably be returning the BFS of that, but it is good that it terminated because that means you didn't have an infinite while loop. So it did eventually reach that end condition. Hey, okay, that's a good sign. We got that right. And let's try it for both. Oh no. Okay, it is working. Perfect. Okay, so I think it's working and I'm gonna submit and see if it did work. Yes, faster than 99% of people. That's actually kind of sick. Okay, and then I'm gonna do this also iteratively, which looks basically the same, but instead of doing it recursively, so instead of calling the same function inside of itself, I'm gonna do it with a while loop. So I'm gonna get rid of this BFS and instead I'll do a while loop, and the while loop is gonna start with the same stuff. So basically it's gonna start with this new node, and that's gonna start as node list, and it's gonna begin with the root node, just like before. And then the new node list is gonna have all of the items appended to it. And we'd want to keep the while loop going while there are items in this new node list. So just so that it starts and it doesn't terminate immediately, I'll just put root in the new node list, but I'll take it out right away, right here. I'll set it to empty anyways. So while new node list is not empty, basically, it's gonna keep going. And for each element, it will append to the new node list. And then I would also need to make the node list equal to the new node list at the very end. So right here, I would set, instead of returning, so this already is done, and at the very end I'm gonna want to return the sum. So here I'm probably gonna want to set node list equal to new node list, and then at the very end I want to return the sum for all of the values in node list, because after this terminates, the new node list will be empty, but the node list should have the last items there. Let me just think about this because it might be wrong. And we don't want to return BFS anymore. So we start with a node list. Let me walk through it. And it has root. And then for each element in the node list, so new node list is empty at this point, we add the left and the right. And then we set new node list equal to node list. And we iterate down. And this should stop working when new node list is empty. So when there are no more elements. And at that point, we would want to return the value of each of the elements inside of node list. Is that right though? I think so. Let me try it. Nope, not quite. Okay. So let's see what's going on. So each layer. Oh, because here I set new node list equal to node list at the very end as well. So how can I get around that? What if I put this here? Perfect, because then new node list is gonna start off by equaling root, and then each time it's gonna get node list, but at the very end it's still gonna have items inside of it. So let's see if that runs. I was trying to test for 15, but let's just submit and see if that worked. And it also works. Slightly slower, but I think that's just a margin of error thing. If I ran it a couple times, I'd probably get the same speed. I could, let me just think. I think I can take this out and it should still work. Yes, it does. Okay, well, thank you so much for watching. I hope the explanation made sense. If you have any questions, leave them down below. And I suggest you try it yourself. It's really fun. Have a great day and peace.